Thanks very much. I'll try to make this quick since we're overall going a bit over time. So it's going to be a bit of a roller coaster. By way of introduction, I'm a director of TAPI and also a CEO of KEF TAPI, which is the prefabrication venture between TAPI and KEF. I think I'm entitled to a little 1-minute description of what we do so that you understand we're rooted in reality, not speaking hypothetically. TAPI is a full-service health planning firm, from preparing health facility guidelines around the world, health service planning, facility planning, healthcare architecture, interior design, project management, and software development. We are the largest and most successful exporter in health and biotechnology from Australia, 3 years running. And we cover this region of the world, locally based in Dubai, here in the GCC, and here in Building 25. So if you want to see us, or any of our 80 people, you're welcome to talk to Tosif, who's sitting in the corner over there. Now, we understand how the world works. We understand private and public hospitals. These are our work. We understand construction techniques in the conventional way. We understand complexity. No worries about that. Why is that necessary? To cut the story short, it's because our mission is planning for the health of people. And the reality is that healthcare facilities take too long to plan, design, and build. Almost every aspect of healthcare costs more year after year. Healthcare takes an increasing portion of the GDP of every country. The demand for healthcare is still rising. So, the future along this path is perfectly predictable, and it does not look good. If healthcare takes an increasing portion of the GDP of a country, it's not just the cost going up in dirhams or dollars and so on, it's the percentage of the GDP. There is no bigger percentage than 100% is there. So if healthcare gets a more of a percentage, what's dropping off the other end of it? Is it schools? Is it police? No, actually it turns out to be social services which support healthcare. And let's have a look at this. This is all the countries of the OECD. The little band at the bottom that you see all bunched together, averaging about 10%. This is the growth of the percentage of GDP of every country in the OECD countries. They're the richest countries on earth. So every year, as that arrow has been going up towards the red, something else has been dropping off the budget. Now, one alone is standing out, US, double that. Which means that at double that rate, other services in the country have been dropping off. Because the healthcare has reached 17% of the GDP is totally unsustainable even right now. By comparison, a country that comes 6th in the healthcare ranking, Singapore, spends only 4.6% of GDP. But then at the same time, India spends 4% of GDP and it's nowhere as good as Singapore. So something is really strange here. So the one that spends as much as double the next richest country, this is the conclusion of a very long article. The first search on Google on healthcare outcomes. Healthcare spending in the US far exceeds that in other countries. US devotes at least 50% more of its economy to health. The excess is likely driven by greater utilization of medical technology and higher prices, rather than the use of routine services, like, seeing physicians and going to hospitals. This contributes to wage stagnation, personal bankruptcy, budget deficit, and creating a competitive disadvantage relative to other countries. It crowds out other forms of social spending that support health. So it's completely paradoxical and contributes to the country's poor health outcomes. What? So spend double and get poor health outcomes? Actually, the rest of this article explains that it's actually the last in the OECD countries in terms of health quality. So what's the way forward? What do we do? Okay, we're frightened enough. We're frightened. We're very worried. What are the options? Well, let's see. What's the consensus opinion between Thelma and Louise? Keep going. Yeah, let's keep going. Right. Let's keep going and hope to get a different result. That was the consensus of opinion from Thelma and Louise. Or there is option 2. Learn the lessons from Industrial Revolution. But the products are today cheaper than they were 20 years ago. Standardize, industrialize, and commoditize. These are the tricks of industrialization. Each one of those has to be complied with, otherwise it will not work. That's the only way, in my humble opinion, that we can make healthcare affordable and sustainable in the long term. So let's look at each one of them. What does standardize mean? Well, look at your iPhone or your Android phone and so on. What's happened? What's happened in the last 5 years? This is a list of features which have been pretty much standardized over the last 5 years, and they've been reduced progressively. So there's only about 2 operating systems left, only a couple of screen sizes left, and you have a camera on the front, a camera on the back, and you have Bluetooth and 4G and hotspot tethering. Okay? Dell is a proud builder of boxes. That's what they make, boxes. Inside the box, what do you have? You have a motherboard, probably by ASUS. You have a processing unit by Intel. You have memory chips from Samsung. You have wires by somebody else, and so on. All of them plug and play. Nothing inside it is made by Dell whatsoever. It's all plug and play. And yet you have this magnificent, highly functional thing, because the components have been standardized and are commoditized as well. So industrialization, what does that mean? Design once and build many, obviously. So if you want one airplane at the level of Airbus A380-800, you pay $13 billion for it. That's the development cost. So the last hospital that you commissioned as a developer, owner, government, how many of those did you build? What? One? Only one? Right. Airbus can be bought for $428 million because they don't build one, they build many. 167 delivered over 8 years, 317 firm orders. By the time they finish, they've made $35 billion. 13 airlines order in this exact model, including Emirates, and they have no shame whatsoever to say, oh, my airplane looks the same as the other guy. No shame whatsoever. They should not have any shame. And when an order came from Air Force One from the US, for just 3 of them, they declined. Just 3? Only 3? No. Give it to Boeing. Anyway, industrialization eventually leads to modularization. Eventually. All of them have resulted in modularization. Bits of cars, a lot of commonality. They don't begin to redesign every knob and button. Now, in our field, we'll get into our field, you can start with modular planning, the basic planning. In the real world, you have to give the clients and all the project managers that know only one type of contract, unfortunately, give them the option at some point to fork. Go the route of conventional design or modular design. At this point, we're softening them up, because up to that point, they don't have to make a decision. Then if they say, okay, go for modular design, then you fork out. You get to a design level where you can go for conventional construction of the same thing or modular construction of the same thing. We're softening them up even more. Now, this part is called soft modular. This part is called hard modular. Design along soft modular and construction along hard modular. So the perfect path would be just this. Dispense with the rest. Get project managers to actually write contracts that allow for this in the first place. Or you can use that and drag and drop it directly into your project, and you have all the information as part of your unique project. Or use your own modules from the past projects into the future projects. And do all of that on your iPad through these apps that I'm showing you. Drag and drop the information from guidelines directly into your project, and the information has come to you. Save a lot of time and money. Now, design needs to be plug and play like all the industrial objects that you have. You plug in a USB into any phone. The chargers now work everywhere. Camera bayonet mounts work this way. So design, plug and play. That's a core on the left, a racetrack inpatient unit on the right. That doesn't work for you on the side. Okay, use this model. You can see the core hasn't changed. Connectivity has not changed. Different models, plug and play, and almost every hospital known to man is reducible to some of these very simple geometries: racetrack, linear, T-shape, L-shape, H-shapes. Just move them around and curve them a little bit, and they give you different geometries. So plug and play. Then use regular grids. We recommend 8.4 meters, and standardize the room types to fit into full grid, half grid, third grid, quarter grid. And build hospital designs out of the units rather than start with a fancy shape that looks nice in the perspective and then carve it into lots of little boxes. That doesn't work. If that was a plane, it would never fly. It would just look good. Now, extremely large and complex plans such as this one, which has now become standard in health facility guidelines of Singapore, have been tested. Every department of the hospital fully modular. There's operating theaters, peri-op, post-op, ICU, etc. So it can be done. Then we have to componentize and standardize room types. Now, each office can do it for themselves. Have your own catalog. We have our own. Every year updated. So do a full design in whatever package you like and derive all of its design elements, including interior design, from that model. So create catalogs for room types, just like car models are built of little different elements of differentiation. Just look at an Audi car catalog and you'll see it. And these will be based on the same grid, and they will be designed to be easy to glue together basically in design terms and construction terms and work to create those big plans. Now, of course, each one of those would be more than a cartoon-looking sort of a BIM model. They would be full interior design, full realistic, that you can show your clients in a catalog for 2016. Next year, you better have your catalog for 2017, otherwise they'll say, oh, that's getting old now. So this is the future of the powerhouses of design catalogs. And once they're assembled, like this hospital that is fully prefabricated in Calicut, India, this is how they glue together to create extremely large plans. What about BIM? Unfortunately, I'm giving you some bad news here. This is about, again, what you might have been told, some happy propaganda, that the industry is getting itself into a nut around BIM. What was the reason for me to promote to you the idea of industrialization for efficiencies and cost savings? Because the unreformed construction industry, the chaotic construction industry, is what's being simulated in the BIM world. So exactly all the same bad practices, all the duplications, all the falling over each other's and so on, all of them are being duplicated in 3D, 4D, 5D, in BIM. What's the use of that? Happily, I can tell you that the future of prefabrication and industrialization doesn't involve BIM of that kind at all. Intelligence goes into the units, not a replica of it on another computer. You take your brand new BMW to BMW service center. Do you think they have a BIM model of your car to look at it? No, the car will talk to their computer itself. It will self-confess, I have a problem in this tail light over here. That is the future of intelligent units, not a replica of it called BIM. That is going to be a passing phase. Now, let's listen to...
When you start to look into the future, you now know that this curve predicts that chips will cost roughly a penny in 2020. That means you now know the future of the computer. The future of the computer is to disappear, to be everywhere and nowhere. Where is running water today? Running water is under your feet. It's in the walls, in the ceiling. Where is electricity today? Electricity is under the floor, in the walls, in the ceiling. When you walk into a room, what is the first thing you do? You look for the light switch. In the future, when you walk into this room, the first thing you will do is look for the internet portal. You will assume that the floor, the ceiling, and the walls are intelligent, and the word computer will disappear from the English language. Just like electricity. No one says that anymore. No one says electricity. And where does electricity come from? You know, the cloud someplace. Who knows where electricity comes from? So in the future, where will computer power come from? It'll come from the cloud. And where is it? It is everywhere and nowhere.
Yes, the future of BIM is that it'll be everywhere and nowhere. Certainly not on your desktop or the basement of the hospital. It will be in the building itself. The building will self-confess what's wrong with it, where is the problem with it. You don't need all these devices to look at a replica of it. Now, the ultimate in hard and soft modular, the ultimate is to go the whole way. Why stop? Not just room modules, but entire hospital modules. Does someone in Africa really care if their 100-bed hospital has a replica in Argentina? Do they care? Do they care if a small community health center that they have in South India, there's one exactly like it in Nairobi? Why? Why should they care? Why should they all be unique? So let's create a catalog of ready-to-use hospitals for those who are in a hurry and are happy to share the same design. And in fact, charge them $0 for the design, just like you don't charge for the design of that BMW. So order that unit, which is a regional clinic, and it comes in modules that glue together in a week, and exactly the same design can be ordered by the hundreds. So that's the smallest unit. This is a mini local hospital. It looks something like that. Again, you can increase or decrease the number of beds a little bit in proportion to surgery and so on. So a few options, just like the options you get on your phone, more memory, less memory, that sort of thing. But otherwise, standardized elements. This is the largest one. You can almost see how it's plug and play, 500-bed teaching hospital, straight out of the catalog. Pre-designed, pre-engineered, pre-costed, $0 design cost, but just get a delivery of the product. Dry assembly, no wet construction, nothing. So let's look at the history of this. How is it assembled? This is year 2000, 16 years ago in Australia. This is north of Sydney. This is a prefabricated hospital with all the walls delivered as flat packs, roof elements, and so on. Windows already there with glass in it and so on, with plastic wrapped. Delivered 120 hospitals in 6 months. On the first day, the minister's opening was already booked. This is a little bit old as a technology now. A bit later on, this is another type which looks like shipping containers, but these are actually customized designs built in China. Two patient bedrooms. You can see the bedrooms on the top right, and 2 bathrooms and a corridor in between, 14.5 meters by 3.7, built in China, delivered across the water to a regional area of Australia at half the price of building it brand new. Cladding people come in, you can see it at the bottom right, and it turns into a fairly conventional building. From inside, you cannot tell. From outside, you cannot tell. It's not a throwaway thing. It's for the largest healthcare provider in Australia, Ramsay Healthcare. This is how it's put together. Look at the speed of this. This is a continuous time lapse. It is before the cladding people come in and finish it off. 2 rooms, 2 bathrooms, corridor in between. The same kind of materials as shipping containers, but much bigger and much wider, much taller. So what did they do just now? They just built 4 rooms and 4 bathrooms and 12 meters of corridor, didn't they? It probably took 2 hours. The whole thing done in a month. Now this is through our JV office in London. Before this time lapse gets to the evening, they will have done 8 of these, which means 16 rooms, 16 bathrooms, and about a third of this 3-story project. This is not like the shipping containers. This is a steel construction, light cladding, sometimes the plastic wrap side, which is open, so it creates larger rooms up to 7 or 8 meters wide. Now this is how they are modularized, like this. So the blue one, the blue joint, indicates that that is a sacrificial joint. If that is removed, which is plastic, hard plastic, it gives you a large 4-bedroom if you want. All the rest of it works through the standard module. Now this is the way they fit together, the base, the middle, the top, and they fall into place just like this, the way that shipping containers lock together. You can go 6 stories high efficiently. The floors are real concrete, so they're fireproof, 2 hours. And this is what you see from the inside. They look completely conventional from inside at least. From outside, slightly strange, but not that much. Now this is the recommendation for 8.4 structural grid, because we're going to talk about full scope prefabrication, not just rooms, everything. A serious construction, 2016, concrete, not plastic and cardboard. So this is from the KEF factory in Krishnagiri for the hospital in Calicut. So you got prefabricated columns, 2 stories high with haunches, but you can have 3 stories too. Prefabricated pretension beams, concrete, and prefabricated floor planks, 0.8 meters wide, and they fit together. These are the whole room modules that go inside them. I'm not talking bathroom pods, I'm talking whole rooms that go inside and plug together. Outside of the units that are highly serviced, like this, before they're sheeted, they go to the site already with plumbing, including the stacks. The stacks also go from factory. They're not done on site. So this is how they're installed on site. You see a room that is almost finished on the left, a room that is half finished, and you see modular MEP, modular all plumbing and air conditioning and so on in the ceiling, and a finished room on the right. And the rooms that came out, they're almost finished. I think there's a soft opening in January. The rooms look like that. All come from the factory. Even the furniture, all the furniture is in the factory as well. Joinery, glass, aluminum, doors, everything comes from the same automated factory. Now, MEP is modularized 6-meter lengths, about 1.5 to 2 meters wide, all standardized modules in the ceilings of the corridors, and then plug and play to the side rooms. So obviously, modular MEP is actually done on the floor and then raised by something that looks like a forklift truck. Now, modularization can be used for fairly complex shapes and forms, although you have to start the modularization from the beginning, not at the end. As I said, you start from inside and you end up with the outside. Or simpler buildings like the bottom one, which is the hospital in Calicut. Now, this is a quick checklist for the designers amongst you. I know there are several of you there. Design must be modular and highly repeatable. It's too late by the time you've started with a fancy shape and you've carved it up. That won't work. Don't expect or offer infinite choice. That won't work either. The factory will say, go away. Standardized room components. So again, it's not sufficient to have the same grid and just varying from room to room to room, just one more feature, one more little thing. You get to the end of the corridor and the window changes location, all these random facades. Doesn't work. Optimize for manufacturing process. Don't expect to have a Revit file given to the factory and say, build this. No. Do you speak the language of robots? Never change during manufacturing and assembly. Now, when you order your BMW, there's no variation. It gets built in Stuttgart, right? It comes. And design once, build many times. Otherwise, don't expect your current one-off design to be built cheaper and quicker in a factory. That's obvious. And yet, there's so much optimism that you can do that. You design your own car and go to the Toyota factory in Japan and say, can you just build this car for me? Do you know how much they charge you? $750 million rather than $14,000. Now, this is a partnership between KEF and TAPI, which formed 2 years ago. So the design studio at the GCC modularizes the design from the inception. So once everything starts from a modular, componentized design of the whole hospital is built out of it, like Lego blocks. Then the factory takes it to another level of shop drawing, which is robot-friendly. Now, this section of the factory on the left builds the columns, either 2 stories high or 3 stories high. All standards are universal. That is just like universal cars or world cars, as they call them, complies with the standards of earthquake zones, other zones on sandy base, etc. One design. On the right-hand side, prefabrication of floor planks, 100 meters long in one stream, and then gets cut 8.4. At the bottom, you see the factory itself. In a factory like this, robots don't look like in the movies. What you see is a robot working on that steel platform that is constantly moving, and is trying to build a concrete wall or floor all by itself, and inside the cage there are no people. So it's picking up steel shutters, fitting them together by magnetic rivets, which are non-destructive, later on get pulled out. It knows exactly where to put the shutters to frame this wall, and the next platform is of course behind it on another track. And it knows where to pick up exactly the right length of shutter to match the design, which is in its mind. Adjust them as it goes. So because it runs 24 hours a day without rest and so on, the throughput is huge. So it goes to another machine which pulls the reinforcement and welds it and places it like this. And then it goes to this section where the project manager should not have been standing on that. But anyway, it goes into this machine that looks like a 3-story high inkjet printer. And capsules of so-called ink, which is concrete polymer mix, will come. The capsule will come and do its job automatically. Here's the capsule coming, 2 of them actually. So where does the capsule go? To the print head. So that pours the concrete polymer mix into the print head. The print head prints the concrete onto that platform, avoiding any holes in the middle of it because it throttles the dot matrix, basically, the mouth. And those guys are just QA control people. They don't do anything. This machine just moves forward. The platform underneath vibrates to smooth it out. Another machine does, at the bottom of that, you can see a machine that lifts it up and puts it on top of another one with reinforcement in a zigzag configuration and creates cavity walls automatically. If you want basement walls, cavity walls gives you. There you go. All the walls are created. Now, inside the other shed, these Kuka robots, same ones that make Mercedes-Benz cars, are cutting and joining sheets and frames, steel frames for the walls. The other machine is welding them together, turning 2D into 3D. The tiling machine pre-tiles all the panels. You'll see the real machine now. Is a real tiling machines that pick up the tiles and tile with 2mm tolerance joint. At the bottom, you can see that these units in a factory run of 100 rooms, starting from the beginning of the room module at this end of it, they're all packed up, ready to go. So capacity, 100 rooms a day. Now, this is the way the site in Calicut was constructed from that factory, which is about 8 hours drive by these trucks from the factory. All these concrete elements have come from the factory. Columns come through. It's basically all dry construction. Apart from the ground preparation, it's all dry construction. These are the pre-tension beams that come through. Semi-skilled or low-skilled labor put these together like Lego blocks. Very, very fast. All dry. There's no propping. These are the floor planks coming. Just drop them in. The joining system takes care of everything. The rooms can come at any time because it's all dry construction and no propping. They can come as this goes up, or they can come horizontally through window openings. The facade also comes from the factory pre-finished. So the structural part is extremely fast. The rooms get manufactured parallel with the structure. So there's massively parallel processes going on here. MEP is already built in the factory somewhere without waiting for anything else. So MEP has probably arrived and is being installed on the ground floor already. Then the finishing elements, the windows come from the factory and all gets finished. All elements. That's the entrance area. We're not talking about throwaway temporary hospitals. We're not talking about builders' sheds. We're talking about serious permanent hospitals here. It's an ICU reception area. And you'll see some of the patient bedrooms as well. This is an ICU room. And this is one of the patient bedrooms. So, as I said, future consultants, designers, and so on, in addition to every other device, brochures and talking at trade shows and so on, will have showrooms of their products. And this is a showroom that we've had here in Dubai for the last 3 years, twice a year. This is this year's one, January 2016. These have all come from the factory and installed in 3 days at the trade center in Dubai. Bedrooms, bathrooms, people can see the quality of finish and fit and look at all the catalogs which will be on the table to have a look at. No design cost, just the product cost and delivery as true turnkey. That's it from me. Please come and see us at the Arab Health 2017, end of January 2017, and you'll find our showroom just like that one, right at the entrance near the fountain. I need to run, but if you have any queries and so on, I refer you to my good friend over there, Tosif Khan, and I'll leave a lot of cards here as well.
Yeah. Thank you very much.
Thanks.